So the first thing I'm going to do, like I did in the previous problem, is I'm going to number my equations so that it's kind of easier to tell which one I'm talking about. If you look at equation 2, do you notice that it only has two variables? It's missing x. So what I want to do is I want to use equation 2 as it is, and then I'm going to take equations 1 and 3 and I'm going to turn them into an equation that only uses y and z. So we're going to use equation 2 as is. So I'm just going to write it down. Y plus z equals 1. And then I'm going to take equations 1 and 3 and I'm going to, I want it to be something that only has y and z, so that means I'm going to eliminate x. So I'm going to write down equation 1, which is x minus y plus 2z equals negative 7. And then I'm also going to copy down equation 3. And I'm trying to get rid of x. So that means I need my x values to be the same number but opposite signs, and they actually already are. If you look at my equations here, I have x and minus x. So those are going to cancel. So when I add these together, negative y plus 2y is just 1y. 2z plus 3z is positive 5z, and then negative 7 plus 0 is negative 7. So now I have two equations, one in purple, one in green, where they both have two variables and they're the same variable. So now what I'm going to do is stack those on top of each other, and I'm going to solve it as a system of two equations. You could do this one either way. I'm going to choose to do this by elimination only because they're both in standard form. So what I'm going to do is multiply both of these equations, I'm going to multiply the top equation by negative 1. It really doesn't matter which one you choose to multiply. So this is going to turn into negative y minus z equals negative 1. And now I can add these two things together. So the y's cancel, and I would have 4z equals negative 8. Divide both sides by 4, and I get z equals negative 2. So now I have one of my three numbers for my ordered triple. So I know that my z value is negative 2. Now I have to go through and I have to figure out my x value and my y value. So I'm kind of going to work backwards now. So I'm going to take my z value, which is negative 2, and I'm going to plug it in to this equation right here. So I'm going to say for my x value, for my y value, it would be y plus z, which is negative 2, equals 1. So I'm going to add 2 to both sides, and I get that my y value is 3. So now I have my y value. The last thing I need to do is my x value. I have to use one of my original equations, and it has to be either number 1 or number 3, because those are the only two equations that actually have the letter x. So I'm going to choose to plug this and this into equation 1. So I'm taking equation 1 and I'm going to plug in y equals 3 and z equals negative 2. So I would have x minus y, which is 3, plus 2z, which is negative 2, and that equals negative 7. So I would have x minus 3 minus 4 equals negative 7, or x minus 7 equals minus 7. And then I would have to add 7 to both sides. I'm going to move this over here a little bit. So I'm going to add 7 to both sides, and I get that x equals 0. So my final answer is the ordered triple, 0, 3, negative 2.